In my last video, I talked about how if you're doing a systems-heavy game, you might want to start your development process off with spreadsheets. But that was a very theory-heavy video, and I think I got a little misunderstood. I think I didn't get my point across very well. Some of the comments I got asked questions like, why are we talking about spreadsheets instead of entity relationship diagrams or mind maps? Or, when do I know how to stop working on the spreadsheet and start working on my game? I wasn't clear. You see, the answer to both of those questions is the same. We're working on our game. This isn't something you do in a planning phase. It's not something you do before development starts. It is part of your development. It is the first part of your development. It is when you put your foot down in the engine. You put your foot down on a spreadsheet because that gives you the best purchase. That gives you the best foundation for continuing your work. The point of having these in-engine spreadsheets is to force you into a data-centric approach. Data-centric approaches are widely regarded as the best approach for game dev because they keep our code from getting too spaghetti-y. And I'm sure you've had this problem before where you've done something that seems like it should be easy, but it turns out to be really complicated because it's related to this other thing over there, which is also related to that thing over there, and you have to do 50 hours of work to do something that should be really easy. That's spaghetti code. That's technical debt. A data-centric approach minimizes that by having all of our data in nice flat tables and all of our processing off in its own little part of the sky and doing its own little thing. We can keep the relationship between them really nice and tidy. And even our processing side, we can limit the amount of interlocking processors there are. So we can try and keep our classes nice and clean and modular and minimize our spaghetti code. And all of this happens automatically if you take the right approach, if you have the right mindset. Now, obviously, you can learn how to do data-centric design and development. It is a process, a skill that you as a programmer can pick up. But if you just focus on tables, spreadsheet, 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 you're already halfway there. Let's say that we're trying to do a battle system. We're trying to program a class that handles all of our battle work. In that class, we have a variable that has to point to the hero. What is the hero? If you're programming naively, you might think, oh, well, the hero is that 3D model with all of the animations and textures and colliders and stuff like that. All of that logic, that's our hero. But if we do that, then anytime anything on the hero's animation side changes, things in the battle are likely to screw up because they're interlocked. And similarly, if we change how the battle works, we might have to completely revamp how that hero expresses themselves and change their animation system entirely. The two things are too tightly interlocked if we take that approach. But if we're already thinking spreadsheet, 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 then when we're asked, where is that hero? What is that hero? We say, oh, that's line 4 on the spreadsheet. The spreadsheet is a nice flat table. We pull the data we need from the spreadsheet and we use it. Oh, do we need to display the hero? Then we have a specific battle hero display class, and it pulls just the values it needs from the table, and it only does that thing it needs to do in the battle at the moment. It's not locked together with a bunch of other animation code for walking around or, pulling levers. It's not locked in with a bunch of visuals for things that aren't related to what we're doing now. It's just the only stuff it needs, and it's all on its own. Same with stats. Our battle stat class can keep track of all of our stats and all of the effects that we have buffing us and debuffing us on its own, in its own little pocket universe. It just takes in the values it needs from the table, keeps track of them for a little while, and then at the end of the battle it spits out the final results. Neat, tidy, separated, contained. No spaghetti. That's our priority when we're developing as an indie developer, because spaghetti is our number one fatal problem. Nearly every indie game dies because they can't keep making progress. And that's mostly because they've chained themselves down with their own spaghetti code. Data-driven development, data-centric development will really help to reduce that. And just thinking in terms of spreadsheets is an easy way to get in the right mindset. So let's do that. Here we are talking about Pokemon. Let's talk about our fake Pokemon game that we're not actually going to make. What would we need? What's one of the spreadsheets we want? We want a Pokédex. The thing that springs to mind immediately is a list of all of the species of Pokemon that we're going to try and catch. Okay, let's do just that. One of the differences between a spreadsheet in a game engine and a spreadsheet in, say, Excel is that in a game engine, all of the columns have to be really rigidly defined. So let's do that. We're going to be using a struct. Most game engines allow you to use structs. Structs are just groups of variables. So in our case, we're thinking of this as the columns in our table. We'll call this found. We'll call this one species name. Oh, call this caught. And then species name, which is going to be a string. A string. Thank you. And then over here we've got the portrait. That's going to be a texture 2D, although obviously that will depend on your exact nature here. It might be a mesh or it could be a sprite. We're going to want health. That's going to be a float. A float. And then we're going to want attack. We can set up the values for this, the defaults, over here. There we go. We now have our columns defined. At this point, some of you are probably thinking, oh, come on, Craig. This is obviously just a placeholder table. I know that we're going to need much more complicated tables than this. What about all of our stats? What about the powers that we learn and what levels we learn them on? What about the stat growth rates? What about catch rates and valuation and how expensive it is to heal and when it can evolve and what it can evolve into? Where are all of those fields? You don't even have types. Yeah, but here's the thing. I'm not giving you a stub for demonstration. I'm giving you a stub because you start with a stub. The point to a spreadsheet-centric approach is that the spreadsheet is where you put your foot. We know where the spreadsheet is, and we know what it will contain. So we can put our foot on it and then use that as a launching pad for wherever else we need to go. When we go into our battle system and we grab the values we need from this table, and then we realize, oh, we actually don't have all the values we need on this table. Rather than panicking and bloating up a class somewhere with more values, you just add 3 stats or however many you need. A spreadsheet is super flat. So if we need to extend it horizontally or vertically, we can just do that. We're never going to entangle ourselves in any sort of complexity because it's so flat. When we need a new set of values, we can just add them, and we know where they should go. They should go in this spreadsheet. This is the species spreadsheet, so anything related to the species will eventually be added here when we need it. Now, I'm not saying you should just dive in with no idea about what you want long term. I'm presuming you did at least some game design work outside of your development process. But this stub is sufficient for us to put our foot on it. And that's really all we need at the moment. Now, that said, this is not a spreadsheet. This is a set of column definitions. A spreadsheet also needs rows. So how do we do that? Well, the easiest way to do it would be to create an array of Poké definitions, and you're probably going to do that, at least some. Let's open up the level blueprint. Level blueprints are a nice tidy way to just kind of noodle around in Unreal because they don't produce any bloat. Oh, did you do something in a level blueprint that you didn't need to do? Who cares? It's just a level blueprint. You can delete the whole level later if you want. So this is a great place to noodle around. In the long run, you'll be adding these same sorts of processes to classes that do more complicated things. But for now, we'll just do it here. We can add a variable. We can call this variable all the pokés, and we can make it a Pokemon definition type and an array. Then when we hit compile, we can actually start to add values. This is a spreadsheet. We now have a species called Yor. This doesn't look much like a spreadsheet, but that's just because it's being displayed in this particular way. Conceptually, this is rows of a specific set of columns. It works fine. There are some issues with just doing it like this. This is a great approach for example, if your hero has a set of Pokemon they're carrying around in their back pocket for battles. You'd have an array of Pokemon on the hero, and you just put the Pokemon in that array. That would be your spreadsheet. Another option would be, if they've got a computer that stores all the Pokemon they've ever caught, you would put Pokemon on an array on the computer. But the problem in a game engine is that arrays have to be attached to objects. Which means that in order to track down an array, you have to track down an object. So for something like a Pokédex, that's a little bit problematic because we want to be able to always point to the Pokédex. The Pokédex should be globally available at all times. If you hang around with indie devs, you're likely to hear them at some point say something like, I got to create another singleton. I hate having to create singletons. Well, a singleton is just an object that is global. And the whole point of a singleton is to allow you to do exactly what we're talking about. Make something easy to find no matter where you are. You could do that. You could make it a singleton in your Unreal game and add your Pokédex to it. But in general, there are better options because Unreal is a pretty mature game dev environment. One of those options is a data table. Let's use it. Data table, miscellaneous data table. There it is. We can pick out our Poké definition, and then we can name it whatever we want. We're going to go ahead and name this Pokédex. There we go. Pop that open, and it is a spreadsheet, more recognizably a spreadsheet. We can call this Bumblyum. Give them an attack that's higher, and then we can make another entry here. Call this Stighumper. There we go. We now have a spreadsheet that's got a couple of Pokemon species in it. No big deal, right? So there's a couple of things that makes this data table better than just using an array in this particular situation. One of the things that is nice is that this already has the ability to be exported and imported from Excel, just by existing in the first place. We can export it to a CSV file by right-clicking on it. Excel can read comma-separated values, so Excel can easily import the CSV. Similarly, Excel can export that CSV and we can re-import it. Now, we don't need this yet. It's unlikely that we want to start in Excel. But next year sometime, we're going to want to put this stuff in Excel for a lot of reasons. One reason is it's easier to email around an Excel file rather than your entire Unreal project. Another reason is you can run a lot of functions in Excel that aren't really available here in Unreal. For example, maybe we want to take the average of everybody's health and see how many rounds it would take any given species to take out the average of everybody's health. That way we can tell kind of how many rounds they'll be in the fight. These functions are easy to do in Excel. They're not so easy to do here in Unreal. So yeah, in the long run, having this conversion between Excel and Unreal will be pretty useful to us. It's good to have it. It comes along with something annoying, which we'll get to in a second here. The other big thing about the Pokédex that is nice is that it's global. We can just access it. If we type in data table here, you can see that we've got a bunch of functions we can use, but the one we want is, of course, the last one, get data table row. We can then choose whatever data table we want, like the Pokédex, and whatever row we want, like new row and new row _ 0. Welcome to the annoying thing about tables. You see, this is not a is not just an array of Poke definitions. This is an array of Poke definitions. An array is indexed by number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unfortunately for us, this is indexed by row name, which is a string. So that would be the equivalent of switching this over to a map with a string as its key, like this. This is the equivalent of the Pokédex, and this is a little bit heavier than we really need. But we have to accept it because we can't tell the table to not do that. It's a little unfortunate. We got to just kind of live with it. Now, if we were already in the Excel phase, this would not be a big deal because the row name is literally just the leftmost column. So in an Excel sheet, you just fill it in normally. But here in Unreal, you can't just fill it in normally because it doesn't appear down here in the editor. For reasons that I don't know and think are very dumb, but we can rename it. Now, if you know of a better way to do this, let me know. I would love to not have to do it like that, but at the moment, that does seem to be the only way to do it here in Unreal. Keep in mind that there is a reason to have the row name be separate from the species name. The species name can have spaces and special characters in it, but the row name can't. So, there is a value to having a separate indexable row name, but it does add a little bit of complexity that we don't really need. We just have to accept it. There we go. Now we got Bumbleyum. We can do this anywhere, in any object, at any time. We can just grab a definition right off of the Pokédex, and then when we got it, we can break it. There we go. Look at all that stuff. If we change our Poké definition to have 3 more stats, then this will have 3 more stats. Here it is. We're done. This is what we needed. We now have the data we want. So you can either fetch it from an array, if you have an array that is doing the job, or you can fetch it from a data table. Either way, at the end, you have all of these values, and you just need the values you need. If we're doing a battle system, we might create a class that just needs the species name and the portrait for displaying your character, right? So that's all we would pull from this setup in order to, actually set that up for our battle visual. If we wanted to do keeping track of the stat, we would copy over just the stats. Now we could store this. We could store a Poké definition like this. Boom. We are now storing it locally. This is our own shallow copy of the Poké definition from the table. But this is usually not necessary, because you only need a couple of values from the table in order to do the work you need to do in this particular area. Like if we're restoring people to health, if we're in a hospital, then we just need to pull off the name and maybe the portrait and whether or not it's injured. We don't need to pull in the entire row forever. So this is a little bit unusual. I want to make it very clear that the data tables that we're using, the spreadsheets we're using, that entire list of things might get pretty big. You might have like 40 or 50 entries, 40 or 50 columns by the end of your project if you're, being a little bit loose with it. You don't need all of that. If you're doing something, then you only need the stuff you need for what you're doing. That's the whole point of this entire process. Whatever you're doing only has a couple of things that you need to do. That should be all you care about. So you copy over the values you need, and then you're done. Now, the reason that is so important and so valuable is because if something changes on either side, all you have to do is change exactly how you copy the value over, rather than rewriting your code. Makes your life easier. So you might have noticed that this is not taking an argument from a variable list. How would we be able to pass this a specific variable? Obviously, this is fine for, if we're just testing stuff out. Maybe in this level blueprint, we set up the basic idea of combat, just so that we can see health go down and test how it feels when the player clicks on something in the level to make health go down, stuff like that. But we don't want to have to define it here on the level blueprint. We would like to be able to tell the level what to spawn by using a variable. How do we do that? Well, there's a kind of variable that we can use. Table row handle. There it is. When we have a table row handle, we can choose the table and whatever row, just like this. See? This will allow us to define whatever Pokemon we want. Now, the thing about this that's pretty neat is that we can point this at any table we'd like. So we could point it at the grand total table of all Pokemon species, but we could also point it at a table that contains, say, specific named Pokemon for specific enemies. Or we could point it at a modded table that takes values from externally, so you can create your own custom Pokemon classes on the fly. We can just change this data table to point at anything. As long as it returns the same value type, we'll be fine. There is, however, an annoyance here, and this is just a flaw in the way that Unreal processes data tables, and I think it's just incidental. I think I'll probably clean it up eventually. It's not a big deal in the long run, but if you're just getting started, it is a little bit annoying. And I'm going to show it to you right now. Here is our target. This is Stighumper from the Pokédex. We would like to fetch Stighumper from the Pokédex. How do we do that? Well, I mean, it's just a struct, right? So we could... only matching structures are considered compatible. Okay, so this does not resolve to a Poké definition, even though it is one logically. What is it then? Oh, it's just a data table and a row name. Yep, that's right. This is how you have to do it. Take the target, break it, reassemble it, and get the row. How annoying is that, right? It's not like it's this won't stop you. It's not something that is going to interfere with you. It's just annoyingly verbose. If only there was a way to make this into one easy-to-use function by right-clicking on it and selecting collapse to function and then naming the function get Pokemon. Oh, there is. So it's easy enough for us to create the functions we need, and we could even turn them into a blueprint library so that we could just use it wherever we wanted. But it is annoying that we have to. It shouldn't be necessary for us to break and reassemble things to get a row out of a table. There should be a much more fluid and easy way to do it. Alas, there isn't, so you're going to have to do it yourself, just like I showed you. But it's not that big a deal. If that is too much of a big deal for you, feel free to stick to arrays. The only problem with an array is that fetching a specific character from it can be quite annoying. With the named rows, you're able to pick Stighumper or Bumblethump or whatever, just because that's what the name of each row is. But if you've got an indexed array, how are you going to pick one from a drop-down list? The only thing you can pick from the drop-down list is the index. So unless you're really, really good at memorizing Pokédex numbers, that might be a little bit challenging. Anyway, this is all stuff that you'll figure out as you move into it and try and work with it. The whole point here is that there are two basic ways to represent a spreadsheet in Unreal specifically. One is an array of structs. The other is a data table of structs. Which one you use depends on exactly where you need the data. If you need it globally, you use a data table. If you need it locally, you use an array, for the most part. Data tables are also something you can edit in Excel and export from Excel back into Unreal. They're also something that is quite resistant to being edited at runtime. You have to go out of your way to actually do that. So it's something that's very suitable for things like lists of species and powers. Whereas keeping things locally in an array is more suitable for things like your specific Pokemon with their specific XP values that change every battle. Taking this approach, whether you're using arrays or data tables, means that you are taking a data-centric approach. You are looking at a flat plane of data, and you're taking the values you need from that location. This will keep your code from getting too spaghetti-y. Okay? That's the basic concept. I hope this was clear. If not, let me know down below. Oh wow, half an hour. Gosh, you guys are patient. See you around.